We have a new OCT. It's called Hyperparallel OCT or HP OCT. And we've developed and we're manufacturing all of this technology ourselves in Australia. A Hyperparallel OCT uses a different internal optical system. So we take a scanning laser and use micro optics and break that single scanning beam into 1,008 beamlets, and they capture a snapshot image of the eye. So a single snapshot image versus a scanning laser means that we eliminate motion artifacts. We don't need to have eye tracking in our product. By eliminating motion artifacts, we use OCT for not only imaging at both the anterior segment of the eye, also the posterior segment of the eye, but we also do complete corneal topography, front corneal surface, posterior corneal surface, all of the biometry measurements, including axial length and also epithelial maps.
So to take a scan, all we need to do is click on the capture button. And there are two different scans that we can do initially. So we've got a full biometry scan, which takes the entire anterior segment as well as the axial length. And then we have a separate retinal scan, which takes a full featured retinal scan. So I'm just going to put in Kylie's refraction and we'll go begin exam. All right, Kylee, if you could please put your chin on the chin rest and forehead on the forehead rest. So the capture technique is automated, so all I have to do is click on OD. I'll just take my hands off the keyboard and mouse, and the device is already aligning itself. So what we need to do is we need to have the pupil inside that circle, and we need the cornea up against this bar here, or this line. So Kylie, have a blink, please. And then don't blink, I'm capturing now. Okay, sit back. So in that time, we took 6 individual scans in one capture.
We're capturing a true volume image. So we don't build an image up by multiple scans. We capture a true dense volume image, and then we can cut it up and slice it whichever way the optometrist would like to see the image. So this is an example of an eye that we've captured in biometry scan. From this single scan, we get a full biometry, including axial length and all the parameters, all of the corneal topography and epithelial maps as well from this single scan.
So this stage just tells you whether we've taken a good scan. So we've taken a scan of the cornea and the entire anterior segment here up until just before the posterior part of the lens. Then we have another scan which includes the crystalline lens, and then we have a retinal scan. And these are all put together to create the entire image. At this point, what the machine is doing is it's registering all of the individual scans, putting them together, and then once it's done that, it'll trace the different layers, so the anterior cornea, the posterior cornea, the anterior crystalline lens, the posterior crystalline lens, and also the distance from the front of the cornea to the retinal pigment epithelium, which is the axial length. And now you can see that everything's appeared. We already have the three-dimensional image of the anterior segment. We've got axial length, we have flap K, steep K, we have central corneal thickness, anterior chamber depth, lens thickness, white to white or HVID, the distance from sclera to sclera, and pupil diameter. And you can see where the software has traced these layers in this horizontal cross-section and the vertical cross-section. Down the bottom here is our retinal trace. We have the peak from the cornea to the retina, and the distance between these two peaks is the axial length. And then we have the anterior topography map, posterior corneal topography, and then a corneal thickness or pachymetry map. In addition to this scan, even though it's not presented on this screen, has already taken epithelial thickness map as well. So that is Kylie's scan. And I could display it in a number of ways. Let's just look at it in a transverse fashion. This is what we call our transverse slice. I can use this green line to scroll through different cross-sections. But just to show you the true volumetric nature of the scan, I can also scan in a radial slice, and you can see that the quality of the image has not changed. We can display the biometry report. This will be really useful for people who are doing myopia management. And then we can drill down into the topography map. If we go into what we call the color map, so that is an anterior corneal axial map. But we can also do a tangential power map of the anterior cornea. We can do a sagittal height map. And all of those same options are from the anterior cornea, but also the posterior cornea. And we can also do things like epithelial thickness maps as well. It does do the retina, and the same sort of thing, it's volumetric in nature, so we can scan it horizontally or vertically or indeed diagonally. and you can see that the quality of the scan does not change no matter what sort of slice we're taking.
We will be launching in Australia later this year, and then we will be coming to the UK in early 2024. So we've come to 100% optical just to really show people what's coming and what they can expect and what they should wait until early next year to purchase their next big capital piece of equipment.